Hello there. Welcome to new video software engineering. In this, we are going to see about formal approach, statistical software quality assurance, and this is part of Unit 5. We are going to see all those things. Formal approach introduction. So, what is formal approach and what is in introduction about this one? We are going to see it's everyone responsibilities, correct? Software quality is shared responsibility of each and everyone, achieved through knowledgeable engineering, means practice. If you have already got experience, that you can able to do very good in this one. And how? Key practices of achievable software quality: technical review of the code, design, and other artifacts help to catch error early. Multi-tiered testing strategies that include unit test, integrated testing, system testing, user acceptance testing, which we are going to see in coming videos. Control flow, product and changes, version control, change management, and ensure consistency and traceable. How the workflow is going on, how the change management are affected it to ensure it's traceable. Application of engineering standard, following standard, industry standard, and best practice to ensure reliability and maintainability. Defining measurement qualities. So there are some qualities which are there. Quality attributes: reliable software perform consistently under specific condition. Effectiveness or efficiency, software user uses resource optimally or perfectly. Maintainability, software can easily be modified to fix, detect, or add feature. Usability, software is user friendly, meets user requirement. Matrix and indicates detect density, number of defects per unit size, like per thousand line, what is the defect of the code. Test coverage, percentage of code or requirement cover on the test. What are the tests? Mean time failure, average time between. What is mean time failure? Average time between failure of the software. We are going to calculate this part later as we move. But MTTF is nothing but average time between failure of the software. What are the failure point of the software? We are going to see this. Formal approach to software quality assurance. First point, mathematical object perspective. Program can be seen as mathematical entities. If is allow mathematical process, it has to rigorously analyze and it has to verify it. If in any mathematical entity is present, it has to analyze and it has to verify rigorously. Okay, that is what prospective of mathematical. Formal method, specify language like Z, VDM, Vanna development method, and B method provide way of precisely defining software behavior clearly and correctness. How the software behave, specify clearly and correctly. Model checking tool like spin and newsim verify the model meet specific properties. What are the properties? What are the standard? There is theorem providing tool like Koch and Isabella help to improve correctness of the algorithm. Means throughout the correctness of algorithm. If there is any mathematical, then what is the proof of it? What is the logical approach? What are the things you have to prove with the help of theorem? What are the tools? Koch and Isabella HOL help to provide the correctness of algorithms that have mathematicals. So that is what it is there. And rigorous specification, define requirement and code, use formal mathematical notation, ensure precious. Mathematical requirement and programming language can easily be specified, ensure exactness and precision. It should be exactness and it should be very precise. This help reducing uncertainty and inconsistency of this software. Correct? A rigorous specification. Then proof of correctness. Mathematical proof demonstrate the program meets specific through formal proofs and historical content based on the history. So these are all approach goes on formal methods. Benefit of formal, what are the benefits of formal method? Accuracy verification of the software. Formal method ensure the software behave for a specific output. Reduce of error, early detection and elimination of detector. Errors are identified and addressed early in a development process. These are benefits. What are challenges? It is complex, difficult in applying for large system. Formal method may be complex and resource intensive. Limited adoption, support by small unwritten segment of communities, and despite their benefit, formal method have seen limited widespread use. So this is the method of formal approach. So in that one we have got what is formal. It's everybody responsibility. What are its key properties, what are its attributes, and how it is approach to software qualities, what are religious specification, what is the proof, and what are the methods, what are the challenges for it. Now we come to statistical method of software quality assurance. That's errors and detect cost. There are few names which are given as incompleteness or erroneous specification. IES means interpretation of customer communication. MCC, intentional diversion of specification. IDS, violation of program standards. VPS, error in data representation. ER, inconsistency in component interface. IEC. So we will be seeing with an example as we move forward all those. Miscellaneous. MIS. So collect the data frequently. These are the parts of errors. These are the errors which is their part. If you are ambiguously inconsistent human interface, there is an error. Error in programming language translation. PTL. IR. So we collect all those one. Example or assumptions. IES. What is IES? Incomplete specification is 20%. MCC means interpretation of customer communication is 18%. IDS is nothing but intentional diversion of specification. These are the error and we have to modify this one. Construct a bar chart to identify vital few causes. Once we got it, construct a bar graph like this or a graph like this. From many you construct a few which are very important. Calculate percentage of error and detect. Identify the top cause accounting the signification. Which are the major causes of this one? That is IES. Example, IES, MCC, EDR. IES is 20%. MCC is 18%, and EDR. This is 20%, this is 1, EDR is 15%. These are the major causes for our things, major parts. So identify in a graph, then you modify it. Top causes. Implement correctness action for vital few. These are vital few causes. Improve requirement gathering. MCC techniques. How do I this one improve this MCC? MCC is nothing but incomplete specification. How do I can complete it? Improve requirement gathering speed. Acquire data modeling tools. Perform strict review. What is EDR? If you see it, EDR is error in data representation. You did not specify the data. Conduct throughout requirement analysis and validation. IES, what? IES is nothing but IES, incomplete testing process. So you are not validate properly. Based, focus on vital. Monitor and iterate. After addressing vital few causes, monitor new data. Identify new top causes and apply continuously improving like a loop. If this is gone, what is the next one we have to do? Ensure ongoing quality improvement. Result of evaluation: evaluate impact of correctness action on software quality. Adjust strategies based on new data and analyze. Focus on continuous quality improvement. Correct? These are the example. These are the things which we have taken. So this is the error 100% as we have taken 2018 5%, which we have covered into table 2018 IDS, correct? 2018 5 2018 5 in the format of this one, and we modify this one and apply correctness action. MCC 18: improve requirement gathering, acquire data modeling, conduct comprehensive requirement analysis and modeling, which we have covered it. Thank you very much.